I'm just realizing my handwriting's terrible. But so this is the banked curve with friction. And this is from the previous video, so I'm just letting you know where it is. And this is how we set it up, blah, blah, blah. But more importantly, this is the final answer. So this is what I got for the velocity, the speed of the car that could ride without crashing, assuming it's going to the fastest speed it could go. The lowest speed we didn't look at. Okay, and I'll probably do that because I'm a sucker. So this is the equation that I want to model in Python. So I'm going to go ahead and start over here in Python. And let's just say some things. Mass of the car, which we don't even need to know. I'm going to say it's 1,000. G is 9.8. Mu, the coefficient of friction, I need to pick a value, 0.5. Theta, let's pick 35 degrees. And I'm going to convert that to radians. I think that's all I need. R, did I get R? No, R. R is 35. I like to use the same thing twice, that's fine, 35 meters. So let me just show you how to use Python as a calculator in case you haven't seen this. I want to get this equation in my calculation. I have it on paper right here. Okay, so let's switch back over here. Now let's just calculate the velocity. This is the equation I had. V equals the square root of R times G times sine of theta plus mu times cosine theta. I'm losing track of my parentheses here. Divided by, I feel like I have an extra, see, so that goes that one. This goes here. Why I have that one? Okay, I'm gonna do it over again. Let's do this. Let's do sine theta plus mu times cosine theta. Then I had to multiply that by R and G. And then I needed to divide all of this by cosine theta minus mu times sine theta. I think that's right. Because let's see. And that parenthesis goes there. Where's this? This one goes there. Okay, I think I got it. So now I just need to take the square root of all this stuff. So say V equals square root of this. Okay. Let's just see if it works. Okay, 25. So I think it works. You got to be careful what entering all this stuff in. Let me say a couple of points. I didn't use the mass. I put it in there anyway. I don't have units here, right? Because if I can put a comment for units if you want. But if you put units in 9.8 newtons per kilogram meters per second squared, then Python treats that as a string or something else. It gets confused. So you have to just use the numbers. So yeah, units do matter, okay? But you are in charge of the units. And then let me say, so I printed that out. I can do this. Max V equals V meters per second. See? Great calculator. And so what's great about this calculator is I think that should be lowercase v. I can go ahead and change what if I increase the friction. Now, the coefficient of friction, if I increase the velocity, should go up. So 0.6. So it was 25.1. So it did. Good. Okay. What if I increase the radius? Then you should be able to go faster. So let's say 39. It did. Okay. So now let's think about this. How do we look at how this whole thing changes? Because I can change several things. I can change the radius of curvature, the angle of the bank, and the coefficient of friction. So I have 3 things that I could change. And when that happens, the best thing to do is make a graph. Okay, so let's plot. Let's do this. This is making a graph. I've covered this before. Graph. X title. Let's change the coefficient. Let's change the angle. Yeah. So X title is going to be equal to angle. Y title is going to be equal to max speed in meters per second. and the angle will be in degrees. You know, this is just for me, okay? Nothing to do with you. Okay, now I can say FA for angle is G curve, and I'm gonna make it blue. I don't know why I always make it blue. I always make it blue. You don't have to make it blue. So now if I just run this, it's not gonna do anything. See, because I never told it to do anything. So what I want to do is start with an angle of, let's say, 0 degrees and move up to, I'm going to pick 70 degrees. Okay, so that means I need to, instead of having theta up here, I'm going to actually say theta equals 0. Now I'm going to calculate everything and make a data point for the velocity with that theta value. And then I want to do it again for a little bit bigger angle and so forth. So I need to say, how big is my next angle going to be? I need a d theta. So let's say d theta equals 0.1 radians, and that's fine. Okay, so now I want to say while theta is less than 70 degrees, which is 70 times pi divided by 180, then do the following. This is a loop, okay? So everything, I need that colon right there, and then everything that's indented after that is in the loop. So the first thing I'm going to do is calculate the velocity. I've already done that. Just need to do it up here. There. Now I need to update. Well, now I can plot. Okay. So I'll say FA dot plot. The x coordinate is going to be theta times 180 divided by pi, because I want it in radians, I mean degrees, and then V. And then I'm going to update theta. And the d theta is for delta theta. Okay, so let's see what this looks like. Oh, it worked. Okay, actually, let's change the name. Banked curve with friction, because I'm going to share that with you because I like you guys. It looks a little jagged. Let's change this to 0.03. It's still jagged right there. It's weird. Okay. Well, that's because it explodes. Why does it explode? It was 1,000. No, it's not. I think it's just because that last data point gets really high. So let's go to 60 degrees and see what that looks like. Because at 60 degrees, I'm getting. See, it's not even getting to 60 degrees. Okay, so I'm happy now. So now I can change this to 0.01. What was happening was that once you have very, very high... Oh, no, it's doing it again. Ah! Let's say pi over 2. So pi, let's say pi divided by 4. Let's do it that way. Okay, so that is right. So pi divided by 3. It blows up again. Okay, let's keep this at something reasonable, like 45 degrees. I think what's happening is that we're getting to a point where you could actually have a vertical wall, and you could go in as fast as you want, right? So as that wall increases faster and faster, if it was a vertical wall, you could go as fast as you want, okay? But with friction, at some point, you kind of get that as fast as you want point. And I think that's what maybe we should calculate at some point. How fast is fast? Because let's go back over here. As you increase your at a very, very high angle, then this normal force increases the friction force, and they both add to this accelerate the force in the x direction to make it accelerate. So I think this is okay. I think let's just keep it right here. So this says as I increase the angle, I can go a lot faster. Okay. Now let's do this. What if I change the coefficient of friction? Oh, what about 0? Oh, 0, I can still go. I can still move, right, because I have friction. Okay, so let's say this is coefficient of friction. and let's go from 0.1, and let's put an angle theta now of, let's just cut this off. I already had 35. And then I need a d mu of 0.01. And so now let's see, all I have to do is change on here while mu is less than 0.8. And over here, instead of theta, I'm going to plot mu. And I broke it. Oh, 0.1. Right here, it can't calculate mu. Oh, I think my mu is too small. What did I do, people? I had it at 0.5 before, right? What did I do wrong? Oh, I don't have theta. I cancel. Aha! Cancel. I turned theta off. Okay. But now it's not plotting. Why? Oh, while mu is less than 0.8. Mu is 0.1. Oh, I never increased theta. I'm such a dummy. Mu equals mu plus d mu. I'm still not doing it. Let's see this. Let's see if it gets finished. It finished, but didn't plot anything. G curve while mu is less than 0.8. It's 0.1. What the heck am I doing wrong, people? Let's see. fa.plot mu v. Let's do that. That plot, so it's not doing the loop. Oh, while m is less than 0.8. Whoa! Okay. Now we got it. So as you increase friction, you can get that too. Okay, now, and then the last thing I did was the radius. I'm not even going to change that because I'm going to just make a mistake. But I'm trying to show you how you can look at this problem, not from one single answer, but a whole bunch of answers. Okay, so here I can change the answer and I can get a whole bunch of, I can explain the whole thing. I could change multiple values at the same time, but then it'd kind of be like you couldn't use a normal graph. But okay, I'm going to end there, and I made those mistakes on purpose. I'll see you guys later.